Okay, so in this question, does it seem like it gives us very much information? Gives us like outright one number, okay? And it would be the displacement of the bolt. Right, so we know that the bolt is going to fall 6 meters. Okay, what else do we know then from the context of the question? Yeah, we have to assume that this is on Earth because we don't know for certain that bolts exist anywhere else other than here. Okay, so we would have negative 9.8, or actually we would say 9.81 meters per second squared down. Okay, and this time I can say down because it is straight down. They give me one other piece of information. Right, what is it? 0. It's 0. Okay, because it doesn't say anything about it being thrown, then it started from 0. It started from rest. Okay, unless you're told otherwise with something falling off of a roof. Okay, that's the same as dropping it. Right, there's no throwing involved. It's not moving at time 0. Okay, so we would say that VI is also 0 in that situation. We're looking for how long will it fall. Okay, so what formula should I use? That's the one I would use. You know that one I told you you'd never have to use to solve for time? Unless initial velocity was 0, which it is in this question. So I can get rid of that. Right? And I'm just manipulating for time. So to get time by itself, divide by half of A, and square root to get T. Okay. Plug in our numbers. Right, we're looking at 6 meters divided by 1/2 times 9.81. I'm making everything positive here because everything was down and there's no need for me to make down negative in this situation. Okay. So, looking for the time. Okay, so square root of 6 divided by 4.905. Okay, so this is going to be falling for 1.1 seconds. Okay. Okay, are those kind of questions tricky? Not once you get all the givens, no, but there were some contextual tricks to that question, figuring out VI was 0, okay, knowing the acceleration was 9.81, all of that stuff is kind of important for solving that question, okay? Okay, let's see if you guys can do that one. Okay, so in this one here, they want us to find the final velocity, so we're looking for VF. Okay, and it is propelled over a 0.30 meter distance, okay, by an acceleration of 22 meters per second squared, okay, for a 0.72 second interval. All right, what formula should I use? I'm gonna let someone else answer, because I appreciate that you want to help me out, and that you probably feel that I feel awkward waiting, but I actually don't feel awkward waiting and waiting and waiting. I've got all the time in the world. I've already passed this class about 1,000,000 times.
Is it, BF squared equals 3L squared plus 2A?
If they told me outright that it started from rest, I could use that one.
There's no time.
Right, but there's no time in that formula.
D equals VFT minus F acceleration.
Exactly. I'm gonna use this one. Okay, I have time, I have acceleration, I have distance. This formula has VF in it as well, so this is the one I would use. So I want to manipulate for VF. First thing I want to do is move the 1/2 AT squared over to the other side because it's not attached to VF. Okay, so to do that, I'm going to add 1/2 AT squared over. So D plus 1/2 AT squared equals VF times T, and then I'm just going to divide both sides by T. That'll leave me with VF, and then I can just plug in my numbers. So 0.30 plus 1/2 times 22 times 0.72 squared divided by 0.72. Okay, so we'd be looking at a final speed of 8.3 meters per second. All right, everybody okay with that one? All right. Okay, give that one a try. That one shouldn't give you too much trouble, I don't think, but give it a try. The big thing here, guys, is I'm just throwing questions at you, and you don't know which formula, because I've told you, the challenge with acceleration problems is not math, it's figuring out what formula to use. Okay, so on this one, it outright tells us it wants the initial velocity, okay, and that it enters ballistics gel. So if you've ever watched like CSI or Mythbusters, they sometimes build the ballistics gel dummy. Okay, ballistics gel is like Jello, except it has the same consistency as human flesh. Okay, so they can tell. They use it basically to test, maybe at what range a person may have been shot from, or the caliber of the weapon they may have been shot with. Ballistics gel really helps in investigating those types of crimes. Okay, so it slows at 150 meters per second squared. So what do I have to do with that acceleration?
Negative.
I have to make it negative. It's slowing down. It's in the opposite direction of travel. Okay, for 0.252 seconds. Okay, if its final velocity is 65.2 meters per second. All right, so there's our givens. Do we have a familiar formula to use for that one? Can we use the sine stand formula? Okay, we go A equals VF minus VI over T. All right, so 65.2 we gotta manipulate, sorry. Add T to both sides, okay? Then for me, I add VI to both sides, right? And then I subtract T times A, so I'll be left with VI equals VF minus T times A, so that'll be 65.2 minus 0.252 times 150. Okay, so 65.2 minus 0.252 times 150 times negative 150. Okay, 103 meters per second, that's a slow bullet?
Yes.
Yeah, that's a very slow bullet. It was already flying obviously for a long time, or maybe it had already gone through something else, like a wall. Okay, sometimes that happens. Okay, just standing behind, like, let's say normal drywall isn't going to protect you very much. Okay, a bullet can go right through that and then hit you on the other side or through a door or something like that. Okay, all right. Questions on that one? Okay, is this making some sense? Okay, because obviously the context of the questions gets trickier as we go along here. But not that one. That one's not tricky. All right, you can give that one a try. All right, so we're looking again for initial velocity on this one, okay? And we know the runner finishes a race at a velocity of 15 meters per second, so that would be their final, okay? And the race was 150 meters long, so that would be our distance. And it took 21.2 seconds. Okay, it's an acceleration question, but there's no acceleration. So what formula do I use? Chris, what formula do I use?
Displacement equals velocity initial equals velocity final over 2 multiplied by t.
Yeah, exactly. Okay, so that one doesn't have acceleration in it, which is good because I don't have it either. All right, so I'm looking for VI. First thing I want to do is divide both sides by t. So d over t equals average velocity, Vf plus Vi over 2. Then I'd multiply both sides by 2, and then I would subtract Vf. So what I'll have here is that Vi equals 2d over t minus Vf. Okay, and so when I plug in my numbers, that'll be 300 divided by 21.2 and minus 15. And so 300 divided by 21.2 and minus 15. All right, so we're looking at an initial velocity of a slightly negative number. Is that okay? It's okay. I mean, if you've ever watched a race, sometimes people in the starting blocks will rock backwards a little bit before they get moving forwards. Okay, that's what the math says. Right? It's not at rest. It's not, you know, abundantly forward, because I coached track for like 25 years. I don't remember any races where you got a running start. Okay, so it does kind of make sense that they wouldn't be moving forward either. Okay, so it's a reasonable answer. It sometimes throws people off because it's a little bit negative, but it's not unreasonable. Okay, so to 2 significant digits, we would be looking at negative 0.85 meters per second. Okay, questions on that one? All right. Now, practical question. What kinds of things in the real world could affect your rate of acceleration?
Air resistance.
Air resistance is a big one. Yeah. What else?
Friction.
Friction. Okay, so rolling friction along the ground. Okay, air resistance is a type of friction. It's just friction between you and the air. Mass. Yeah. Okay, mass. I mean, for something falling, it doesn't make any difference theoretically. Okay, if you were in a vacuum, all masses fall at the same rate. Okay, if you're going over hills, yeah, it makes a difference. Okay, if we're talking about a car, obviously, like mass, that's where it makes a difference, because your engine, if you have 2 cars with the same powered engine and one is heavier, it's obviously going to take longer for it to accelerate just because it's more mass. Okay, anything else?
Would wind direction happen for something?
Wind direction, because that increases your wind resistance, okay, or reduces it if it's at your back, right? Okay, so let me ask you this. You're in the mountains and you're skiing and an avalanche is coming towards you. What's going to accelerate faster, you or the avalanche? Why? Well, I mean, it is already, I mean, you could also already be going, but why is it going to catch you most likely because it can accelerate faster than you. Mass doesn't make too much of a difference in that situation. I mean, it could make a little bit. What do you have to do if you're skiing?
Dodge like trees and stuff.
Yeah, exactly. You've got to change directions periodically. You probably are not going to have a wide open slope, and even if you do, just pointing your skis straight down the hill and tucking in your poles is probably also going to wind up with you dead. Okay, because you're just going to pick up so much speed. And if you had the slightest little bump or something like that, you could get thrown, and then you'd be under the avalanche anyway. Okay, so I'm going to show you a little video clip here. This is something that Mr. Dickey and myself have been working on for years. We collect bad movie physics videos, and then we go over them with you to go, this should be like one of those things where you just look at that and go, that's so wrong. Okay? One of the key elements in good movie making is called the suspension of disbelief. As you learn more about physics, it is more and more difficult to suspend your disbelief. Okay? Because some things are just dumb in movies. Okay? Especially today. There's such an overuse of CG to make things look just ridiculous. Okay? That it's hard to look at a movie and go, oh, I believe that. Because it's just so outside the realm of what's actually possible. Okay, so I'm going to show you a video that has an avalanche in it. All right, so car moving backwards down a hill at -3 meters per second. So VI is -3.0 meters per second. Driver gets the engine started after 2.5 seconds. Okay, car is moving up the hill at 4.5 meters per second. What's the acceleration? Pretty straightforward. Don't even have to manipulate for that one. Okay, just plugging in our numbers. 4.5 minus -3, okay, over 2.5 seconds. Okay, give us +3. All right, here's the plan going forward here, guys. I'm not going to spend any more time on acceleration. Okay, it's just algebra. So you guys understand what acceleration is, so now it's just a matter of can you solve problems. Your unit exam will probably have 2 acceleration problems on it. Okay, so know that that's something you're going to need to be able to do. It's also a huge part of projectile motion, which is the last thing that we do in this unit. Okay, so being able to use, manipulate, and solve acceleration problems is an important skill. Next week, we are going to be moving on to vector addition. Okay, that is where the trigonometry comes in. Okay, so on Monday we'll start simple vector addition. Okay, like forward and backwards, which we already kind of know. Then we'll move into perpendicular vectors, and then we will move into non-perpendicular, non-linear vectors from there, which we'll probably spend quite a bit of time on. Okay, so that's kind of where we're headed right now. We will have a lab next week on acceleration, okay, but I'm going to use it to kind of break up the vector addition because we've been doing that for a long time, okay, but we will have a lab on acceleration. Last thing, your labs for the position versus time lab are due on Wednesday. If you have questions or need any help, or you'd like me to read yours over before you submit it, okay, pop in and see me at any of those help times or nighttime next week on Monday or Tuesday, okay, and I'd be happy to do that for you. Okay? Questions from you guys? All right, well, we'll call it there. We've got 3 minutes left in class, but